algebraic fraction. An algebraic fraction is one where both p of x and q of x are polynomials and the q of x is not equal to 0. Why is q of x not equal to 0? Are we able to answer the question? Before we do partial fraction, we need to understand what is an improper fraction and what is a proper fraction. Right, an improper fraction is when the degree of p of x. Okay, what does degree of p of x means? Example, if your p of x is equals to 4x cubed plus 2x squared minus 9, right, the highest power is 3. In this case here, we say that the degree of p of x is equals to 3. So an improper fraction is when your degree of your p of x, which is the numerator, that means when the degree of your numerator is the same or more than the degree of your denominator, then this is an improper fraction. A proper fraction is when the degree of your numerator is less than, strictly less than the degree of the denominator, then it is a proper fraction. Let's look at some examples of what proper fractions and improper fractions are. I think it's quite clear from the examples on the screen. Right, I'm just going to pick one to explain. If you look at the proper fraction, let's look at example 2. So 4x means 4x to the power of 1, and 2 can be written as 2 times x to the power of 0, because x to the power of 0 is 1. Right, so 4x to the power of 1 plus 2x to the power of 0, the highest power is 1, hence it has degree 1. And if you look at the denominator, if you take x squared times x, that gives you x cubed, some other terms, but the highest power is 3, so that is degree 3. So this is a proper fraction because the degree of the numerator is less than the degree of the denominator. Right, so let's look at improper fraction. Let's try to pick one example. Let's look at example 1. Now, if you look at example 1, the highest power is 2, so that is degree 2. If you look at the denominator, highest power is 2, that is also degree 2. So the power of the numerator is the same as the power of the denominator, hence this is an improper fraction. We have just learned into practice. Right, let's do activity 1. Put a tick at the correct column. Right, so if you look at the first algebraic fraction that you are given, is that a proper or improper fraction? Right, this is an improper fraction. Why is this an improper fraction? Okay. If you look at the numerator that is of degree 2, and if you look at the denominator that is of degree 1, right, so the degree of the numerator is more than the degree of the denominator, hence this is an improper fraction. Let's look at the second example. Right, if you take x times x, that will give you x squared and some other terms for your numerator. So that means that your degree of your numerator is a 2. And if you look at the denominator, it's also degree 2. So when both the numerator and the denominator have the same degrees, it is an improper fraction. Let's look at example 3. Right, so if you were to take x times x squared, that will give you x to the power of 3 and some other terms. Right, so the degree of your numerator is 2. However, for your denominator, the degree is 3. So hence, the degree of the numerator is less than the degree of the denominator. This is a proper fraction. Let's look at the last example. So based on the same reasoning that we have done for the first 3 examples, we can clearly see that this is an improper fraction. Okay, because the degree of your numerator is 5. And the degree of your denominator is 4. So this is an improper fraction. We learn partial fractions because partial fraction actually help us to break a huge algebraic fraction into simpler forms. And this partial fractions, it's very useful in the topics of calculus when you have to integrate or differentiate huge algebraic fractions. Then if you can break it up into smaller partial fractions, it's more manageable. Right, so if you look at activity 2, on the left hand side, this is what you have learned in your lower secondary. This is how you learn how to combine 2 algebraic fractions into 1. So we have 2 algebraic fractions here, 3 over x plus 1 and 4 over x minus 2. Right, so we can find a common denominator. The common denominator would be x plus 1 and x minus 2. And then you simplify it, and then this will be what you get. So now we have to reverse the process. Okay, let's reverse the process. Let's say that this algebraic fractions I've highlighted in yellow for you on the left hand side. We want to break it up into 2 partial fractions, into 2 partial fractions to make it more manageable. Right. So if you look at where this partial fraction come from, it's from 2 fractions, 3 over x plus 1, and the other one is 4 over x minus 2. Right, so if you were to look at the denominator, they are made up of linear factor. So the denominators are actually linear factor. And the numerator are just a constant. That means it's actually a degree smaller than your linear. The linear factor, the degree is 1. But your numerator is a constant. Let's say 4, you can write it as 4x to the power of 0. This is degree 0. Okay, so from there we can actually let your algebraic fraction 7x minus 2 over x plus 1 bracket x minus 2, we can actually break it up into 2 partial fractions, right, where one of them is a over x plus 1 and the other one is b over x minus 2. So a and b are 2 constants that you need to find. So the common denominator would be x plus 1 and x minus 2. And then you do it. So you take a times x minus 2 plus b times x plus 1 for the numerator. Right, and what we're going to do is have to find the 2 unknowns. And this become an identity. Because what we have here is 7x minus 2 over x plus 1 with x minus 2. So you can actually compare the numerator because now the denominators are the same. Okay, let me highlight it for you. The denominators are the same. So therefore, the numerator would have to be equal to each other. Okay, and this is what we have learned earlier on. This is similar to the concepts of solving identities, where you can use a substitution method to find the constants a and b. Right, so I'm going to eliminate a, so I substitute x to be 2, because if x is 2, 2 minus 2 will be 0, 0 times a will be 0. So I eliminate a first, so that I can find the values of b. Right, so I let x equals to -1 to eliminate the values of b, so I can find my values of a. So hence the partial fractions for this algebraic fraction will be 3 over x plus 1 plus 4 over x minus 2. And you can see that the right hand side is actually the reversed actions of what you have done on the left hand side. Right, so now let's put what we have learned into practice. So if you look at what we have on the screen, if you have a proper fractions, do you recall what the proper fraction is? It's when the numerator, the degree of a numerator is less than the degree of a denominator. That's a proper fraction. And if you're given the proper fractions where the denominators are in linear form, right, then we can actually break your algebraic, you can break your algebraic fractions into partial fractions of this form. So let's look at example 1. So this is a proper fraction. Let's check to verify it's a proper fraction. The degree of your numerator is 1. And if you look at the denominator, x times x will give you x squared and sum up the terms. So this one, your degree is 2. So hence this is a proper fraction. Right. So what is the first step? We're going to let this proper fractions, proper algebraic fraction. We know that this can be simplified into 2 partial fractions. The first one is a over x minus 1. Okay, there are 2 linear factors here. Okay, let's look at your denominator carefully. There are 2 linear factors. Okay, x minus 1 is 1 linear factor. This is first linear factor. LF stands for linear factor. And your second one is your x plus 3. So this is your second linear factor. Okay, so there are 2 linear factors here. So we can separate it into 2 partial fractions, where the first one is a over x minus 1. The second one is b over x plus 3. Okay, so this is the first step. Then the second step is to combine these 2 partial fractions, right, back into a single algebraic fraction. So how do we combine them? Common denominator will be x minus 1 and x plus 3. So the numerator will be just a multiplied by x plus 3, b multiplied by x minus 1. Okay, so what's the next step? The next step is that we have to compare the numerator on the left with the numerator on the right. So the numerator we're going to compare is, on the left is a 16x minus 28, this one here. And on your right will be this one we have highlighted in green. Okay, so this one will form an identity we've learned earlier on. So there are 2 unknowns there, a and b. Alright, so I'm going to eliminate constant b first. So I'm going to let x equals to 1. So you have a of 1 plus 3, that is 4. Of course, this one will give you 0. Then that will be 16 times 1 minus 28. So 4a will be equals to negative 12. A will be negative 3. Alright, so we still have to find the value for b. So I'm going to let x equals to -3 to eliminate the constant a. Right, so I would end up b bracket -3 minus 1 equals to 16, -3 minus 28. That will be -4b equal -76. So b will be -76 divided by -4 gives you 19. Right, so therefore your partial fractions will be this algebraic fractions, alright, will be equals to two partial fractions. The first one will be -3 over x minus 1. Second one will be 19 over x plus 3. Let's put what we have learned into practice. Please try to do these questions on your own. The answers are given to you here. Right. To start you off, okay, let's check if this is a proper fraction. Yeah, the degree of a numerator is 1 and the degree of your denominator is 2. Yes, so this is a proper fraction. Right. If you were to observe the denominator, right, this is a quadratic polynomial, and for quadratic polynomial we can actually factorize it into two linear factors. So your first step is to factorize the quadratic polynomials into two linear factors. Okay, and then you can break it up into, express it into two partial fractions, a over your first linear factor plus b over your second linear factors, and then you solve it as accordingly. And if you don't get the answer, please do not give up. Try a few times and I'm sure you can do it.